So as I was mentioning before, everything warmed up here, a lot of this chapter is all the same. It's just find your rejection region, find what the critical score is, and see do you fit in the critical score or not. And if so, you can reject the null, and either that means you reject the claim or you support the alternate. It depends on how that works. So given binomial, remember binomial means that each trial has the same probability. For example, flipping a coin is a great example of binomial because each individual trial should have the same probability, right? 50-50. And to use this, though, we have to make sure NP and NQ are greater than or equal to 5, because remember that is when we get something that is at least somewhat normally distributed. If we get outside that, it gets a little iffy. And it says if you know both of those are greater than or equal to 5, you can actually just use the z-test, which means what kind of distribution are we going to look at? Are we going to look at the t-chart, or we're just going to look at the normal, right, and find some z-score? Our test statistic here that we're trying to test and see if it's any good is p-hat, and the standardized test stat is that z. Standardized meaning we've moved it and aligned it to that normal distribution. That's why it's standardized. And it may look somewhat familiar. What we're basically going to do to find our z-scores, we're going to take p-hat, which is our kind of our sample, minus p in the claim, right? That's the p that would be in the claim. So this is what we found when we did a sample. Whoops, I covered up the hat part. There we go. That's what we found when we did a sample. That's what's in the hypothesis somewhere. That's what somebody has said. The proportion is greater than or equal to 50% or something like that. That's the number that we were given. And then this p down here, notice there's no hat on it, right? So that's just the actual p. Now where's the q come from again? Yeah, basically it's the complement, right? 1 minus whatever p is. And then notice, instead of splitting it up like this, they just wrote it under one radical, right? Remember, that's kind of, and really this is the standard deviation for, because the square root of PQ is kind of that standard deviation for those binomial ones, okay? And so that's why they have that. Because remember, it's always over the square root of n, but this one's just a little bit quicker, right? So don't think it's like a double square root, like a square root there and a square root there. It's just one, okay? Everybody good with how to get the z-score of that? So that's how we get the one that we're trying to test. To get the other one, you use your table, all right? So let's actually try one and see. Let's try and get one going here. I think it's easiest just to jump into it because we've already looked at a normal distribution plenty, right? So let's get this thing out of the way. There we go. So some researcher out there claims that less than 20% of American adults are allergic to medication. It's an interesting claim. In a random sample of 100 adults, 15% say they have such an allergy. Test the researchers' claim at a level of significance of only 1%. So that, we're really going out there. What's probably something we should check before we even go any further? Yeah, are they both? Now, let's face it, we've got, what's P here then? P is what would be in the hypothesis. Is it the 15% or is it the 20%? 20%, because 15%'s, in this case, P hat, right? So if I take 20% times 100, are we going to be okay? Yeah, NP is pretty, it's 20, right? And NQ is going to be 80, so we're good, right? We don't have to necessarily check it, but we always, you should think about it at least. Well, let's write these down. Seeing we know, whoa, what is that? Seeing we know we can do it, let's go ahead and find these, because then we'll figure out what tail we're talking about. All right. So we know, what have we been putting here? We've been putting mu, right? Well, yeah, it's P. Yeah, so P. And then we're saying that the claim is that less than 20% of American adults are allergic to medication. So where would you kind of put that less than 20%? Is that saying less than or equal to? Yeah, that's your alternate because there's no equal to on it, right? And so in other words, this one down here is the claim. So the best I can do with this claim is support it, right? And so then up here has to be greater than or equal to, because we want everything else to be there, right? So what tail are we looking at? What tailed test? Left tail. Which is rather handy, seeing that's what the normal distribution does, is it gives you the left part of the tail, right? So we have to go find our Z critical score. Like what's the cutoff, basically? And so we need to look in our table, and it would help to know we're looking at n of 100, we're looking at 0.15. So what do we really want to be in here? How much? 0.01, right? Or in other words, 1%, right? So in other words, we got to go find, yeah, well, how does your table do that, though? Remember, if you take out your standard table, it actually takes it to the left. So we actually just have to go find 0.01, right? We'll find 1%. And so, hello, where are you? Oh, there it is. All right, so we have to find, it's definitely negative, very good, because remember, in the normal distribution, this is approximately 0, right? For a z-score, so we know this is definitely negative. And so we're trying to find 0.01. So it's somewhere in here, right? And what number have we been using pretty standard at this point? Well, I haven't been. I've been using negative 2.33 myself, because that's pretty close. So we'll use negative 2.33. Now, let's say this test actually comes relatively close. Then might we kind of adjust that a little bit and see, because obviously it's not perfect, but you know, that's what we've been using for our cut score or our critical value. Okay, now what? Yeah, now we got to go, well, what is z for this particular one? And so z is equal to p hat minus p over the square root of no hats over n, right? So in other words, in this one, what is p hat? 0.15, very good. That's what they went and found in a sample somewhere. Minus 0.2 over the square root of 0.2 times 0.8, right, because that's what q would be, all divided by 100. So let's go ahead and figure that out, however you're going to do that. Well, at least we have a shot at being negative, right? Had we gotten 0.25 here for a p-hat, we wouldn't even be testing this thing because it had no chance of being negative, right? But this one actually does. I don't know. I don't know if it's going to be enough or not. I have an inkling of no, but because 0.15 isn't quite far enough away, but we'll find out what you come up with. So go ahead and calculate your actual z-score. Perhaps we'll put that right here so we can compare it to the negative 2.33. Well, we know it's negative. We'll do that. So you should be doing that now. I heard a negative 1.25. Okay. So what does that mean? Yeah, that's like right here, right? So I'm not, because negative 2.33 is right there. Right. So fail to reject the null, which in this case means not enough information to support the claim. That's not saying the claim's wrong. I just don't have enough information. Okay. At a significance level of 0.01, if I start changing the significance level, perhaps I could, right, support the claim. But in this case, with the information given, I cannot. Okay. And that's a general idea. You know, you just basically figuring out your critical number and then figuring out your actual statistic is the key, and does it fit in there or not? I mean, that's all this chapter is about. Once you figure out how null and alternate works. Okay. All right, let's give this one a whirl, and then I'll send you on your own. Why don't you read this one first and tell me how this one is different from the first one. True, it would be right-tailed. That is a difference. Not the one I was looking for, but that is true. Okay, 0.05 for level of significance. Yep, that's different. Yeah. What weren't you given specifically this time?
There is enough evidence to see.
Well, we don't know that yet. We don't know if there's enough evidence. We were given p hat specifically last time. Here we have to go find it. Is it overly difficult? No, but we have to go find it. But the first thing you should always do is say, wait a minute, what if if p, q, and NP and NQ are big enough, We got 55% and how many people? 425? I think we're probably okay. Yeah, I don't think we really actually have to do that, right? I think we're all right here. But again, keep it in mind. Don't just breeze over it. You know. The reason that it has to be above that is otherwise we can't use a normal distribution, and then what do you do? Well, you got to try something else. So we're going to use P again, right? And so what's the claim here? That more than 55%. So that greater than 55% is going to go where? Somebody kind of already mentioned that it was going to go here, right? Because it was mentioned that it's going to be a right tail. So then less than or equal to has to go there. Okay, and the claim is in the alternate again? Is it? Or you decide to test the claim? Yeah, well, let's face it. To do that, it has to be down there, right? All right, so then we know it's right-tailed. It's over there somewhere. And how much do we want in there? Basically, 5% to be in there, which means we want, exactly, we need to find 0.95 because the normal distribution table gives you the stuff to the left. Doesn't give you the stuff to the right. You think that's what it is? Well, you would hope so, right? I mean, you should know this one, but let's say, oops, you had a little bit of a, I can't quite remember. You would just go in here and find 95, and as you can see, it is kind of, this one, it is pretty much right in the middle, right? I mean, there's no guessing on that. It's pretty darn close. And so that's where your 1.645 has been coming from, right? And so that is your critical z-score, so 1.645. And I'm glad you're starting to make that connection to some of those, because really that comes from, remember, when there's 90% in the middle, because that'd be the other 5% on the other side. So that's good that you're making that connection. So let's go ahead and get it again. So you take p hat. Well, how do you get p hat on this thing? No? Yeah, this is what the survey found out. That 225 out of the 425 actually did that, right? So p hat in our sample is 225 over 425, and I think we're going to have to round that a little bit. So we'll do 0.53. Does that sound good for p hat? Which is pretty close to our 0.55, right? Pretty close, although they have widened our rejection region a little bit there, but I don't know. That's really grasping at straws on that one, I think. I don't think we're going to make it, but at least it's positive, right? So at least has a chance. Is it? Oh, yeah, it's negative. So we can probably stop at this point. Because no matter what we do, this z-score is negative. So it's, and if you actually do it, it ends up being like negative 0.8. And so why even keep going? This is a no shot. Okay, so we fail to reject the claim, and you can't. So we fail to reject the null, excuse me, and so we cannot support the claim. Yeah, this was actually a typo. That was supposed to be 255, but I figured why not leave it in there and see if you realize, you know, that's negative. I kind of like doing that sometimes. Typos turn into good things. And it was not the TA that happens to be in this classroom now. He is apparently on his way to some other state that's not continental. So any questions on that one? All right, so try the last one on your own, see what you come up with. See if you can do that one on your own. It's very similar to that one, and see what you come up with. At least this one's, what, 4% away, so at least this one, you know, you're thinking maybe, who knows, we'll find it. So I'll pause it while you do that. All right, let's give it a look, see what happened. All right, did you just breeze over the whole actually checking to see if we can use a normal distribution? Or did you actually think about it? Yeah, it has to be more than 5, but in 23% you might be nervous, but then you see it's 200, so we're all right. Okay, and so that would have been really mean if I had you work on that whole time and you weren't actually supposed to be. All right, what's the null? P equals 23, very good. So then P does not equal 23, and where is the actual claim this time? Again, if it says right there, we're hoping it's up here, right? And so this makes it two-tailed. And we're basically saying how much, so 5% total, so 2.5 on each side, right? And one way of looking at it, or in other words, you could say 95 in the middle, and so it is your critical, positive and negative 1.96. Again, it's one of those more popular ones. That happens a lot, but again, if you were looking for it, I would have actually looked for the 97 and a half total, right to the left, and that's one that's actually right in here because it is the most common, and so you put those together, and there's your 1.96. And so then you go get Z, and what do we got? 0.27 minus 0.23 over, and we got what, 0.23 and 0.77 over 200, and Z is, well, in this case we know we're not looking at the negative, right? We're looking at the positive, and what do we get? Yeah, 1.34 is what I got, which again means can't reject the no, and I cannot, not enough to reject the claim. Yep, because I can't reject the no. So not enough evidence to reject the claim. So let's say on this one, we were supposed to reject the claim, because we didn't, right? Let's say it actually was wrong. What type of error was that? Is that a type 1 or type 2? Yeah, it's type 2. What's type 1 again? When you reject it and you weren't supposed to. Here, hypothetically, I was supposed to and didn't. Okay? Yeah. But that actually is rejectable here. I don't know. Did you type the Z wrong in your calculator, maybe? Did you have 1.96 as your critical? Positive or negative? So, did you use, well, no. I was thinking maybe you use p hat for these down here, but no, that probably wouldn't do it either. Yeah, I got it? Yep, that would do it. Makes your top a lot bigger. Okay, so as I told you, it's very similar to all the other ones. It's just you got to know where do you look.